Can you get this GRE quantitative comparison practice question right? Because 94% of people don't. I'm Erika, and today I want to share the hardest GRE quantitative comparison practice question in the Target Test Prep program. This is a weird one because this question was designed to be easy, but only 6% of students get it right. I'm going to show you how you can be one of them. Let's jump in. All right, if you want to give this question a go on your own, pause the video here. Now, before I get started, I'm going to go ahead and get rid of all the language from these answer choices just to give myself room to solve. Now, if you're watching this video, you should know these by heart, so hopefully it shouldn't be a problem. Giving the question some a quick glance, I can identify that this is a number properties question. There are a lot of number properties words here: positive, odd, integer. So I know going into this question that I am going to be thinking about number properties and how different number properties can affect our math. All right, digging into our question stem, the product of m and n is 24. Okay, pause here. M times n equals 24. Continuing on, n is a positive odd integer. Okay, so n equals positive odd int. All right, at this point, we can jump into our quantities. Now, before I approach this the right way, I want to show you the trap that most test takers fall into. Now, in a lot of quantitative comparison problems, we have to manipulate our quantities, but here we just have m and n, or really n and m. So there's literally nothing to do other than to start coming up with possible values for m and n. And I'll make a little table to stay organized. Now, notice that I am putting n on the left side of my table and m on the right side. And that is because n is my quantity A and m is my quantity B. And I want to make sure that I don't get them mixed up because we probably expect in our brains for these quantities to be in alphabetical order, but they're not. It's not mn, it's nm. So we really don't want to get them mixed up. That is an unforced error that we do not want to make. Okay, so I will start with factor pairs, right? So my first one would be 1 and 24. So 1 is a positive odd integer, which means that this is a possible value for n, which means that this is a valid set of values for m and n. Now, in this case, m is going to be greater than n, 24 is greater than 1, which means that quantity B is going to be greater than quantity A. This means that we can rule out answer choice A, quantity A is greater than quantity B, and answer choice C, the two quantities are equal. All right, next up is 2 and 12. Okay, 2 is not odd, so this is not a possible value for n. This is not a valid set of values for m and n. Eliminate. Okay, after that is 3 and 4. Okay, 3 is another positive odd integer, so this is another possible value for n, another valid set of values. Okay, in this set of values, once again, m is greater than n, so we can't do anything. We are still between B and D. All right, beyond that, we're just going to go through our previous factor pairs again, but switched around. So 4 and 3, 12 and 2, 24 and 1. But in all of these pairs, n is not odd, which it needs to be. So these are not possible values for n, which means we can eliminate them all as possible sets of values for m and n together. All right, here's where things fall apart. At this point, most test takers go, okay, I'm all out of factor pairs. And in all of the valid cases, quantity B was greater than quantity A, right? M was greater than N. So my answer is B. Quantity B is greater than quantity A. This is wrong. Now, I'm not surprised that many students get to this point. This is the most straightforward approach to the question. It is how I started this problem too. What I am surprised about is that so many students' next step is to submit and move on. Because at this point, major alarm bells should be going off in your head that this question was suspiciously easy. We've got simple quantities, we've got simple factoring, we've got a seemingly straightforward solution. In other words, not much critical thinking. And we know that critical thinking is what GRE math actually tests. So let's back up and ask my favorite question when a problem feels a little bit too easy. What's the trap? Well, other than the quantities being in reverse alphabetical order, there's nothing in them that could be a trap. They're just too simple. So let's review our question stem and the information we pulled out of it. Okay, so we know that m times n equals 24. Okay, I don't really know what to do with that. That seems pretty straightforward. Okay, we know that n is a positive odd integer. Okay, well, what about m? Well, our question stem doesn't say anything about M, so in theory, it could be anything? Now let's dig into that a bit. We remember that this is a number properties question, and we know that different number properties can really change our math. So let's think about the different number properties that M could, in theory, have. And let's go ahead and use the number properties that define N as a guide. Okay, we know that n is positive, but m could, in theory, be positive, negative, or even zero. Well, actually, no, it can't, because we know that m times n is positive 24, and n is positive. M must also be positive. Okay, strike one, that didn't tell us anything. Moving on, n is odd, but m could, in theory, be odd or even. Well, actually, we've already taken advantage of that in our factor pairs. In fact, if n is going to be odd, m cannot be odd because an odd times an odd is never going to be an even like 24. So we've already dealt with that. Strike two. Moving on, n is an integer, but m could, in theory, be an integer or a non-integer. Huh. Well, hang on a minute. Because when we made our table, we were only considering factor pairs, we didn't engage with the possibility of n being an integer, while m is a non-integer, something that's neither odd nor even, but a third thing. So let's go ahead and try out a non-integer value for m. So I'm going to do that by assigning a valid value for n that is positive, odd, and an integer, but that is not already a factor of 24. So I'm going to go ahead and choose 9. Okay, now plugging that into my equation up here, I'm going to get m times 9 equals 24. Okay, dividing both sides by 9, I'm going to get m equals 24 over 9. That reduces to 8 over 3, or 2 and 2/3. All right, adding that to my table. Now, because I followed the rules set for n, this is a possible value for n, which means that this is a valid set of values for n and m. M can be anything as long as this equation is true and our rules are followed for n. So this is valid. And in this case, instead of m being larger than n here, n is greater than m, which means quantity A is greater than quantity B. This means that I can rule out answer choice B, quantity B is greater than quantity A, and I am left with my correct answer, D. The relationship cannot be determined. So in order to get this question right, 1, we need to be very fluent with the concepts involved in number properties. 2, we need to organize our work so we don't make a silly mistakes in doing something like mixing up the quantities. And 3, we need to be very cognizant of when a problem is feeling too easy so we can go back and ask ourselves, what's the trap? So did you get this question right? Let us know in the comments. And if you'd enjoy more hardest question videos like this one, give this video a like. Thanks for watching, and I'll see you in the next one.